All right. Hi, guys. We are on section 1.7. If you do have your workbook now, you should follow along with me on page 52 and 53. Before we get started, we are going to take some notes on that side column, and then we'll dive into our examples. As you can see, we're going to start at number 2, so we will be skipping around a little bit. So the first notes that I want us to go over are a couple of terms about angle pairs. Okay, so we kind of touched on this in the last section, so I'm going to start here. We have two different types of angle pairs with names like complementary and supplementary. And I'm going to leave a little space in the middle. So my complementary and supplementary. Remember, I gave you my little devices to help you remember. Complementary angles add to 90 degrees. Supplementary angles add to 180 degrees. So remember, like people say it's a compliment to look younger than you actually are. So think that 90 is less than 180. It's a compliment to be younger. So go for the smaller number. You can also think alphabetically. C comes before S and 90 comes before 180. So the alphabetical order and the numerical order go together. Those are good ways of thinking about it. So if angles are complementary, they add to 90 degrees. If they are supplementary, they add to 180. So some other terms, as you can see, we're going to use a lot in these diagrams. We have, I'll keep the green. I like the green. We have vertical angles. Vertical angles look like this. These two angles that I draw are vertical angles. They are angles that are across from one another, but they share a vertex. So, opposite angles share a vertex. And the vertex is this point right here where the two angles come together. So, vertical angles, I call them bow tie angles. Kind of helps me remember them because they make like the shape of a bow tie. The vertical angles, however, can be like this. And so in that case, they kind of look more like an hourglass if it's these angles. Or they just kind of look like an upside down bow tie. Whatever way you want to think of it, these are the angles that are bow tie angles, the ones that you can trace out a bow tie. Okay? I like to call them bow tie angles because that helps me remember that these angles are congruent. Okay? They are congruent, which means they are the same or equal. Same or equal. The reason that helping or remembering them as a bow tie helps me remember them is because I think about like if I was wearing a bow tie, would I want my bow tie to be way bigger on one side and smaller on the other? No, we straighten out our bow tie in the mirror. We would want it to be equal and congruent on both sides. And then lastly, I know I'm kind of running out of room down here. I was writing too big. We have a linear pair. Linear pair are angles that form a straight line. So any angles that come together to form a straight line, such as two angles like this, where this is one angle and this is the other angle, those are linear pair. You can also have a straight line and you could have multiple angles. So you could have this, this, this. Anytime you have angles that come together to form a straight line, those will always add to 180. Those will always add to 180. Any angles that come together that form a straight line are going to add to 180, which we also just learned the name for is supplementary. Hopefully you guys wrote smaller than me. If you ran out of room, you can write over number 1 because we're skipping it. So complementary angles add to 90, supplementary add to 180. Vertical angles are opposite of each other, but they share a vertex. They are bow tie angles, as I like to call them. They are congruent. Linear pairs are angles that form a straight line, which means they add to 180, which means they are supplementary. So we're going to go ahead and take a look at number 2. It says find the measure of x and then the measure of each label or each angle. So I have 2 angles. They are opposite of one another. They share a vertex. And in my opinion, they kind of look like a bow tie. And so these are going to be vertical angles. Vertical angles trace out a bow tie. Remember, we wouldn't want our bow tie to be bigger on one side and smaller on the other. We want our bow tie to be perfectly symmetrical and equal, which means these 2 angles must be congruent with each other. So this is congruent. If 2 angles have the same marking inside of them, so like 1 line or 2 lines or, anything that denotes that those 2 angles are the same, it means they are congruent. So when we talk about angles, we say congruent, but when we talk about numbers, we use the word equal. We don't say 2 plus 2 is congruent to 4. We say 2 plus 2 equals 4. So shapes, lines, segments can all be congruent, but numbers are equal. So the value of this angle, 6x minus 45, is equal to the value of the opposite angle, 4x plus 5. And now it's not really a geometry problem anymore. It's more of an algebra 1 problem. I'm a big fan of drawing a line down the middle of the equal sign because I know mathematically I can only do things once per side of the equal sign. So I'm trying to get the x's on one side of the purple line and the plain numbers on the other side. So the first thing I'm going to do is I'm going to add 45 to both sides. You could have dealt with the x's first. I just like to deal with the plain numbers first and do the x's second. So this cancels out, and I have 6x equals 4x plus 50. Now, I want to get all of the x's on the other side. So I'm going to take away 4x's on this side. I'm going to take away 4x's on that side. Those will cancel out. And now I have 2x equals 50. And then lastly, whenever I have 2 numbers that are next to each other, I am going to divide to undo the multiplication. And I'm left with x equals 25. So that was the first part of my problem. Now I got to plug it in. So I'm going to plug in 6 times 25 minus 45. And I'm going to plug in 4 times 25 minus 45. Or sorry, plus 5. And so in both, I should get 105 since they are congruent angles. So part B is the same thing. I'm going to move a little faster this time. A, because it's a video and you can pause me and rewind me if you need to. And B, because it's just like example 1. So I'm going to trace out my angles. I've got 1 angle, 2 angles. It's a very tall and skinny bow tie, but it's a bow tie nonetheless. It shares that vertex in the middle. So remember, I want my I want my bow tie to be equal. Remember, bow tie is a vertical angle. The problem is I say bow tie angle so much that you guys forget that they're actually called vertical angles. So that's important. Don't forget that. So that means that this angle is congruent to that angle. So I'm going to go ahead and write the value of this angle, which is 8x minus 20, is equal to the value of this angle. Remember, I'm a big line down the middle person. I like to get rid of the plain numbers first, and I always move my plain numbers to the right. So I'm going to undo minus 20 by adding 20. Then I have 8x equals 5x plus 57. Then I'm going to subtract 5x, so I'll change my color. Minus 5x minus 5x. Ooh. That'll cancel out. If I have 8x's and I take away 5, I have 3x equals 57. And that is going to, we are going to divide both sides by 3. And x is going to equal 19. You could do that part on a calculator, 57 divided by 3. You don't need to know that one by heart. And then I'm going to plug them back in. So I need to find out what 8 times 19 is minus 20, and what 5 times 19 is plus 37. Let me grab my calculator because I do not know my multiplication tables for 19 as well as I know them for other things. And so I have 8 times 19 minus 20, which gives me 132. So both of these angles are 132 degrees. And then lastly, we're going to do one more. We're not going to write a 2-column proof, but it wasn't worth it for me to change the wording because you guys have the same words on your paper. So I'm just going to go ahead and kind of show you what I want to show you with number 4. So we're not going to write a 2-column proof, but we are given that angle 4 is 35 degrees. So the first thing I'm going to do, remember we learned that M, angle sign in a number, means measure of angle 4. So the measure of angle 4 is 35 degrees. So I'm going to find 4. I'm going to draw my angle, and I'm going to say it's 35 degrees. Okay, remember your angle is always the swoosh. So I always like to include an arrow. So I remember that from here, traveling to here, that's my 35 degrees. The measure of angle 1 equals the measure of angle 2 and angle 4 combined. So how do we find that the measure of angle 3 is 70 degrees? Okay, so we know that the measure of angle 1 is the same as the measure of angle 4 and angle 2 combined. We know that the measure of angle 4 is 35 degrees. We also know that we have some vertical angles and some linear pairs. So let's say anytime I see a straight line, all of the angles that come together, so this angle plus this angle plus this angle, always have to equal 180. And I can say that about any straight line in this picture. So if I pick this straight line, then angle 1, angle in the middle, and angle 4 would have to add up to 180 because every straight line is 180 degrees. Again, I can pick this line right here, and not only does this angle plus this angle plus this angle equal 180, but the other side as well. This angle plus this angle plus this angle equals 180 as well. So I know that angle 4 and angle 2 are bow tie angles. They are opposite angles of each other when I go from point to point to point for angle 2 and I trace out angle 4. They make a bow tie. I know that when they make a bow tie, or sometimes it looks like an hourglass if it's more vertical, that those are vertical angles and that they are congruent. So if angle 4 is 35, then angle 5 is also 35 degrees. So it says that angle 1 is equal to angle 2 plus angle 4. So angle 1 is equal to angle 2 plus angle 4. So if angle 2 is 35 and angle 4 is 35, then angle 1 is 70 degrees. And so then the question is asking, how do I know that angle 3 is also 70 degrees? That's because I should be able to find another bow tie. So if I trace out angle 1 from endpoint to vertex to endpoint, and I trace out angle 3 from endpoint to vertex to endpoint, I should see a big bow tie. And that bow tie lets me know that those two sides are congruent and that angle 3 is 70 degrees as well. The bonus question, though, that they didn't ask, but I am going to ask, is to find out what these mystery angles are right here. And we are going to use linear pairs to do that. So I'm going to pick this line right here, and I'm going to say that angle 1 plus angle 2 plus angle 3 has to all add up to 180 degrees. That's half a circle rotation. So I can do a bunch of things. I'm going to say 70 plus 35 plus, and you can do whatever you want. You can do plus question mark because we don't know that angle. If you want to be a really strong mathematician, you can write x because x always symbolizes a variable that we don't know. But all I know is those three numbers together equal 180. So in order to get x by itself, I'm going to subtract 70 on both sides, and I get 35 plus x equals 110. And then I'm going to subtract 35 on both sides, and I'm going to get x equals, that is 125? No? 9? Oh no, I'm doing that so wrong. Sorry. It's hard to think when I'm doing these lessons live. You might be faster than me. 110 minus 35 is 75. Sorry, that was so hard for me. And so that means that this mystery angle is 75 degrees. And therefore, you can do it two different ways. You can say, oops, I lost a 70. You can say that these are vertical angles. So if this angle is 75, this angle has to be as well. Or you could have done a straight line and counted up these pairs as well, and known that 70 plus 135 plus 75 would give you 180. All right, so that's all we have. Remember, if you have any questions, comments, concerns, oh my gosh, that one looks so small compared to the other notes. Again, if you have any questions, comments, concerns, make sure you email me, Canvas message me, text the phone number that's linked on Canvas. And yeah, I love you guys. I miss you. Keep doing good work.